So welcome everyone. This is Sri Krishnamurthy, the host of the QuantUniversity Winter School. And it's 2021, January 27th. And I'm very excited to see you all here online. And I hope that today's session, you'll get a big picture on what are the various innovations which are happening in machine learning, especially in the financial services world. It's going to be an introductory session. Last week, we had an amazing session by Luis Serrano, who presented an amazing workshop on quantum machine learning. We have had a lot of questions about the winter school and the courses we are going to be offering and how it's going to relate to the learning for this quarter and many of the courses we're going to be doing this quarter. So I thought I'll take this opportunity to kind of share some of the things we've been doing here at QuantUniversity and some of the opportunities, the learning opportunities you'll have this quarter. And I'm going to go through some of the upcoming lectures so that you'll have some opportunities to put it in your calendar to join us over the next 3 to 4 months. And in addition to that, I'm going to share some of the lessons I've personally learned on how the industry is adopting AI and machine learning in the last year or so. And I'll just kind of use my crystal ball to talk about some of the themes which I would like you to think about when you're focusing on some of the things you'll have to learn, especially with all the changes which are happening in the world. This session was supposed to happen 2 weeks ago, but I started the year with a proverbial bang, if you will. The whole family came down with COVID, and I had to take a 2-week break, and I'm recovering. And fortunately, we didn't have to go and hospital, and we were able to relax. If I but I guess we are back and for the winter school. So let me get going. I'm going to share my screen and share some of the slides I prepared for you. And as most of you know, my name is Sri Krishnamurthy. I've been running QuantUniversity since 2013. And in the last couple of years, we have focused primarily on the intersection of science, machine learning, quantitative finance, and in context. And as a quant myself, back in the day at Citigroup, I had the opportunity to work on a lot of large-scale systems and technology systems. My training was all in machine learning and AI, and I was able to see the power of how you could bring in automation, how you could bring in the power of technology in the financial services world. And in the last 7 to 8 years, I have had the opportunity to see the whole AI and machine learning ecosystem grow tremendously, both from an academic perspective, but also from practitioner perspective, with all the industries like Google and Microsoft adopting various frameworks and tools to enable use of machine learning within the enterprise. I also am a faculty member at Northeastern University, where I have been teaching machine learning and AI for the past 7 years. And I kind of remember the day when in 2013, I would introduce basic Python programs and Jupyter notebooks, and students would get fascinated. And by the end of the semester, they would have offers to become data scientists. But nowadays, they are kind of asking very specific questions. When are we going to talk about model serving? What metrics do we think about to measure data drift and concept drifts and things like that? So it's fascinating to see how the whole ecosystem has grown. And what we have also been doing at QuantUniversity is putting together various programs. If you go to quantuniversity.com, you'll be able to see many of the educational programs we've been hosting. We used to do a lot of in-person events, and we used to do a lot of teaching at customer sites and also in various locations. But over the last year, we have taken everything online, and you don't have to leave your living rooms, and you will be able to dial in and watch these sessions. We've been partnering with the CFA Institute, with Premier, to bring in joint offerings so that you will have the opportunity to learn. But we're also doing a lot of things on QuantUniversity.com. So if you're interested, please do go and check out some of the programming out there. So what I intend to do over the next 30 to 40 minutes, and I'll give you sufficient time for asking question and answers, is I'm going to talk a little bit about the winter school and some of the sessions we have in store for you. My team and I, we've been reaching out to a lot of amazing speakers, and we've been bringing a lot of new concepts and new topics to the winter school. With the generosity of all the speakers and all the ecosystem partners, the Wednesday and the Tuesday afternoon lectures are going to be completely free. So you will be able to access the slides, access the training materials over the next 8 to 9 weeks. So just think of it as a learning opportunity, you dedicating like an hour a week trying to learn these concepts. But I'll also give you some opportunities wherein you can join us for extended programs so that you can gear up on technologies, gear up on labs, get hands-on with many of these concepts. And I try to bring in that notion of how do you operationalize things rather than just understanding concepts? How do you make this real and practical? And I've had the fortune of working with more than 1,000 students at various capacities. And the one thing I've always learned is the more you do, the better you become as a practitioner. So I'll talk about some of the themes we have been focusing in terms of education materials in 2021. And I'll also show you some demos on the kinds of things you're going to be working with as the session goes. So let's get going. Quick recap. I do want to acknowledge the support of all the amazing speakers we have had over the last year or so. We kicked off the summer school way back in June, July, and we had an amazing set of speakers who came down, and every week they presented various topics in optimization, synthetic data generation, model validation, interpretability, use of machine learning in finance, leveraging various aspects about model validation, and also looking at the entrepreneurial ecosystem on how various companies and investment opportunities have been presented in the context of AI and machine learning. So we had amazing speakers and amazing topics, and I'm so glad to have worked with all of them to put together all the materials. And then we extended that into the fall school. And in the fall school, again, we had a whole theme on AI and machine learning enablement. And we had a bunch of courses, and we also had amazing speakers on synthetic data generation, on fintech, on leveraging various aspects of responsible AI and ethical AI, and also looking at how do we operationalize AI, and looking at the whole notion of explainability and interpretability in machine learning, which are really hot topics. And as you kind of start adopting machine learning, you'll realize that it's not just about the technology. You have to contextualize it on how these will be applied in the enterprise and what are the various themes you have to look at, not only because it is the right thing to do, but also because the ecosystem and your end users, all the stakeholders are expecting you to have thought through the whole process. And we also looked at various data vendors and how they are augmenting their traditional data offerings with machine learning offerings. So we had more than 30 speakers. We had people from 13 different countries participate in our programs. We had 2,400 plus participants in various workshops. And we had people from the Fed, from PwC, Goldman Sachs, OCC, EY, Deloitte, Genpact, BNP Paribas, Fidelity, State Street, Discover, Charles Schwab, et cetera, take our courses. And I'm so glad to have all of them in our QuantUniversity alumni network now. They're interacting with each other, and they're getting to know each other, and also bringing the discipline of adopting AI and machine learning in practice to the next level, and learning and sharing all the things they've been doing. So we have had people who were data scientists, quants, risk managers, consultants take these courses. So if you have questions about like why you should be taking some of our courses and offerings, this is just an example of the kinds of people who've been taking courses. So I'll just kind of spend a few minutes on what we have in store for winter. In winter, we are primarily offering 4 courses, and we actually have 2 more courses which are going to come late in winter. But the first 3 courses are primarily geared towards people who want to get a firm understanding of, what does AI and machine learning mean from a practitioner perspective. So we start out with, let me just kind of go to the site so that you can actually see some of the programming we'll be able to offer. 1 second. So in the Winter School, we have these 4 courses. So if you go into the Winter School site, it's the basic course for adopting Python as a language for building data science programs. This is primarily geared towards people who are really new to data science and who want a good grounding on what are the various packages which are available. All these are going to be done over Q.Academy, which is our learning platform. It's all cloud-based. You don't need to install anything. And we have all the labs set up for you, so you will be able to practice the various sessions. The second one is a machine learning course, and this is an 8-week course, and we focus on the various themes on machine learning, providing you a broad introduction to some of the applications. And then we delve deep into topics like exploratory data analysis, unsupervised learning, and supervised learning, and neural networks and synthetic data generation using natural language processing for various applications, and some of the frontier topics. And all of these modules have extended case studies so that you not only see the usage of these applications, but also you can build upon it, and then you can see how these are actually used in practice. And the third course is primarily geared towards understanding the notion of risk in the context of machine learning, especially when you're building out machine learning programs in an enterprise. You don't have to just build a model and deploy it, what you do in an academic setting, but you have to think about well, what are the options which are out there? What does it mean to use AutoML versus building a model from scratch? How do you validate these models? How do you think about the whole life cycle of the model? How do you think about testing, measurement, interpretability, reproducibility, scalability, tracking, et cetera, et cetera? So we have a whole framework called as the Decalogue, and we introduce you to the various themes on using machine learning models and focusing primarily on the risk of machine learning models within the enterprise. And we talk about use cases and case studies, but also give you a framework for how do you pragmatically adopt machine learning models within the enterprise. And we talk about open source products, we talk about vendor products, and how do you leverage and integrate APIs within your enterprise? How do you quantify machine learning risk and model risk? And also some of the best practices and validation criteria. And we've built out templates on various things. And this is something we do as an enterprise. We do algorithmic auditing for various companies, and we have built out frameworks to validate these models. And we share the best practices on what we have learned in the field. And as I mentioned, we have a lot of consulting companies and a lot of risk managers who are building out best practices for model validation for machine learning models within their enterprise, take these courses and use it as a launch pad for building out their own practices within their enterprise. And we also have a case study where we kind of walk through what does it mean to do validation of these models within enterprise. So that's kind of your third course. So we have had whole departments within organizations take these courses and gear themselves up towards these 3 modules. And I'd highly encourage you to join us. And this time we are partnered with Premier, and all these 3 courses are available in an on-demand mode. But we are also planning live sessions in February, March, and April. So stay tuned for that announcement. But if you're interested in joining us now and want to take this course on demand, these courses are readily available to be taken. And we also have a new course on Fintech. We call it the Fintech Bootcamp. And for people who are observing the whole Robinhood phenomenon and looking at various options in payments and transfers, and we've been tracking the blockchain related topics. So we have a new course which is coming up. So I would highly encourage you to take a look at that. And also this is a snapshot of it, and we'll be releasing the program of this one too. So that's a little bit about some of the courses which are coming up in the winter. And as I said, these are courses which I would encourage you to take if you want to kind of think about using your next 8 to 12 weeks to learn something new and concretely kind of build your profile, learning from practitioners, working with other practitioners, and discussing various themes and building out a project portfolio so that you can gear up towards adopting machine learning within the enterprise. But if you're just interested in kind of joining us every week and learning about new topics, so we have an amazing set of speakers we have lined up for the winter school. We are going to have Patrick Hall, who was at H2O, but he's also a faculty member at George Washington University, and he wrote this amazing paper about what to do when AI fails, AI incident response, and he's going to be speaking about that next week. And then Anupam, who founded Truera, who's also a professor at Carnegie Mellon University. So he's going to be talking about AI and interpretability in machine learning on February the 10th. And then February 16th, Nadia and Marco, they wrote a really cool paper on explainability on supervised machine learning. It's readily available on archive, you can download it. But they're going to be speaking about explainability in supervised machine learning. And then on 23rd, we have Daniel Duffy and John Mark talk about Hilbert space kernel methods for machine learning. Some cool research they have done, and I'm really fascinated to hear about their discussion on the 23rd. And then on March 3rd, we have Raghu from Discover, who's going to be presenting. They wrote a white paper partnering with H2O and other entities on machine learning considerations for fairly and transparently expanding access to credit. So these are like the confirmed speakers till March 3rd, but we have 4 to 5 other speakers. Hariom Tatsat, who wrote a book on blueprints for financial machine learning. So he's going to be presenting, but then we also have a couple of other speakers. We are kind of just making sure we set up the timeline. So you'll be able to like join us, and all these sessions are free. You just need to go to the Winter School website and register, and you will be getting invitations from us like you've been getting, and you can join us every week. And if you have speaker recommendations, or if you want to present, if you've been working on something really cool and you want the world to know about it, please do reach out to us, and we'd be happy to see if it's in alignment. We'll definitely bring it. We're also trying to create a forum wherein we can democratize the learning of machine learning related topics. We have been fortunate to live in an era wherein the contributions of open source providers have made it such a rich ecosystem. I remember back in the day when I used to work for enterprise software companies, we had this tunnel vision of, how do we just promote one product or one particular area, but we're seeing this beauty of, democratized evolution of machine learning. And we want to foster that thinking process and build a community so that you kind of share your knowledge and also leverage other people's contributions so that we as a community can build upon and build robust products and adopt it within the enterprise. So I encourage you to reach out to us if you have speaking ideas or you have recommendations for speakers, and we'll see how we can accommodate that. And we also are putting together new programs, and I'm just sharing this slide because this is in our roadmap. And my team and me, we're kind of working towards putting together various programs on machine learning, model risk management, which is some of the things in our forte, and also fintech. And by the way, the fintech class I was mentioning, so that's actually offered as a graduate MBA class at Northeastern University, where I teach in the business school. So it's going to be a similar kind of an exposure to case studies and other aspects, but we're also thinking about like creating some kind of an incubator so that we can foster those ideas. We're partnering with various companies. If you have any ideas or if you want to reach out to us and engage, please do feel free to reach out to us. So that's a little bit about the Winter School Kickoff. I just wanted to share some of the things we had been doing over the past 8 to 9 months and what we intend to do over the next 14 to 15 weeks. And if you are interested, just go to QuantUniversity.com and all the registration information is available. And we've been reached out by many people from different parts of the world on discount codes. We are also offering some discounts through Premier. But if you join us directly, just use the code QFAffiliate and you'll get $100 off for any of the courses. By the way, all the contributions, if you are paying for a course, that helps us create more programming and helps us create more guest lectures and more content available to you all. So all the proceeds are very well used. And last year, we announced $30,000 worth of scholarships for students who are participating in the Premier Research Challenge. And we offered scholarships to more than 50 students from various parts of the world. All of them are graduate students who are looking for their first opportunity, and they had the opportunity to take our courses. And because of all the contributions you've been making in terms of joining our courses and learning with us, we were able to make that scholarship available to students. So I thank you all for the support on that. Okay, so that's a little bit about the Winter School. I hope you join us and hope you continue to be engaged. So let's talk a little bit about what's happened in machine learning and what do we see in 2021. And I love the slide on the various ways in which machine learning has progressed over time. And my undergraduate degree was in mechanical engineering. And I remember the day when I was just fascinated by how you could use hydraulics to lift things, and how you could use pulleys and gears to accelerate the way in which you could do things. And fast forward now, we are leveraging computers, we are leveraging parallel and distributed computing systems, we are leveraging GPUs to accelerate computations. I remember 10 years ago when I would do stress analysis and scenario analysis, sometimes we would be restricted with the laptop or the desktop we had. And I had even a client who would say, I can only do 10,000 simulations because despite using all the processors I have and all the memory I have, that's the extent to which we could go. And today we are able to leverage all these technologies, and we're seeing the whole evolution of the ecosystem. And that's basically creating technologies which we never thought was possible before. And we are seeing how autonomous driving is progressing, how we are able to see flying machines and all the cool things which we are seeing. Though these may seem well, it's just kind of cool stories we can potentially see on some kind of a BBC documentary. No, these are technologies which you and I can download today. TensorFlow and PyTorch and various other platforms which are powering many of these innovations are just available with the click of a button. In fact, with Google Colab and other technologies, you don't even have to install anything. You can just click a button, fire up your deep learning model. With transfer learning, you can download models which are already pre-trained with millions and millions of parameters and adopt it to your particular use case. So the way in which the world has progressed, you don't have to start from scratch. You have the tools and you have the ability to kind of start innovating and build upon the innovations other people have done. And that's what's happening in the world. When you see the world starting to innovate, you see an exponential increase in research. And we have seen, this was the WIPO's site, and I provided a link below. You can see the number of scientific publications which have gone up in the context of AI and machine learning. And you can see this huge increase in the last 10 to 15 years in the number of papers on various machine learning related topics. And if you look at drill down, you can look at topics like neural networks, support vector machines, rule-based learning, deep learning have significantly gained focus. But the cool thing I really found interesting was the patent families, wherein companies are not only just researching these, they're looking at it and contextualizing it for their particular use cases and saying, well, this is IP, which is so unique and that we want to patent it and we want to use it. And we see a significant increase in the patent filings in enterprises in all these topics. And what that means is many of these technologies are not just restricted to academia. There are practical use cases, companies are realizing value, they're adopting it. And what that means is you have seen many companies now slowly migrate their workforce towards aligning them to using machine learning and AI. And many financial institutions are expecting you to be conversant and to be experts in various AI and machine learning technologies. And what that means is, in the future, when you are working with your colleagues, they're all very comfortable with leveraging machine learning and AI. And it means that you are no longer at a state wherein you are kind of looking at these as like ideal applications which are happening somewhere in a research lab. These are practical things which everyone will be adopting within the enterprise. So just kind of to set the stage, there's a lot of discussion on AI and machine learning, and many times it's used interchangeably on what AI and machine learning means. But primarily we are looking at, how do we leverage algorithms and learn from patterns? And if we have seen things happen in the past, and if we have data which relates to what has actually happened in the past, how can we leverage that information and build out models so that we can do predictions? But it also, in the context of AI, augmenting those lessons learned from the past with also, rules and intelligence, how you could potentially, display it as been displayed by humans. So I've given you some sources for people who are really getting oriented with some of the terminology, so please take a look at it. But I wanted to contextualize it because, when we talk about a model in the financial services world, and this is a publication, the SR 11.7, wherein we kind of, talk about like, well, how do you define a model? And it basically says, well, a model consists of three components. This is verbatim from the paper. An information input component, which delivers assumptions and data to the model. A processing component, which transforms inputs into estimates. And a reporting component, which translates the estimates into useful business information. So this is kind of a simplistic view of what a model actually means. But guess what? This is how the ecosystem looks today. And I pulled this today from this LFAI, and this basically kind of looks at all the ecosystem products which are out there and what's actually happening in terms of innovation. And as you can see, and they kind of have like 270 plus different frameworks and members in this chart. And you also have this like investment in the range of around 17 trillion has gone into AI and machine learning innovation. And you can kind of see that it's no longer just defining as a model and input and output. So you can kind of see this whole ecosystem of machine learning in here with frameworks and platforms and libraries. This is the whole ecosystem of deep learning, various frameworks, platforms, libraries, and tools, reinforcement learning, various programming related aspects where you can see open source products like Julia come up. And then you also have like notebook environments wherein, we don't really require to have just an editor. You can basically interactively build programs and see how your results come out through Jupyter notebooks and Colabs and things like that. But then you start looking at, well, you need data because all these are data-driven products and you have different kinds of data sets. And how do you think about versioning of data sets? How do you store your data? How do you think about feature analysis? How do you think about operationalizing many of these data sets? How do you think about streaming data? How do you think about SQL and visualizing data sets and pipeline management and labeling and automation and governance? So all these are becoming themes which an organization needs to think about. And the reason why this is important is, as an enterprise, you're no longer just focused on quants and data scientists building models. You have to start thinking about the whole ecosystem because the power is not just in the model, it's in the whole ecosystem and optimally being used so that you can build upon it. And then you have the various modeling related aspects. And in some ways you could see things like, well, I already have pre-existing workflows. Or there are tools like Amazon SageMaker or Google or Microsoft related products. There are interchangeable formats like Onyx, which you can use for maybe building a model in MATLAB and using it in a Python context or vice versa. There are marketplaces wherein models are built and sold, made available as services. There are ways in which you can automate some of the training so that you can leverage your hyperparameters and train it appropriately. There are tools for benchmarking like MLPerf. And then there are also ways in which you can accelerate your machine learning, like technologies like NVIDIA's for inference and other means. And then you also have like the compute engines where you have to think about like parallel and distributed computing, various interfaces. And obviously security and privacy is becoming is a concern, especially if you're working with private data sets. And then you have various vertical applications where you have to think about like natural language processing or computer vision, etc. And then you also have some of the key themes which are being discussed nowadays, which is like bias and fairness and explainability. So when I started looking at this ecosystem, I was like, well, there's so many things happening and everybody is like, focusing on one particular theme. And what does it mean for an enterprise when you have to start building things? You had to pick and choose what actually makes sense for you. And you had to think about like, how can you contextualize your particular use cases and pick and choose various components which actually make sense. And many of these products are actually being evolved, in academic and open source settings, but they are leveraging the ecosystem in the cloud and other hardware vendors to basically accelerate some of these processes. So what that means is, in the past, if you were hiring a quant, you would potentially say, well, I'm just going to think about many of the things I would learn in the mathematical finance program or financial engineering program. And those would be like, statistical based, and I'm going to leverage the historical data sets and build out models because I don't have a lot of data. And then I'm going to start thinking about specific models for different asset classes. Guess what? In today's day and age, a lot of quants are now learning about some of these cool technologies because now they're working with alternative data sets. They're leveraging some of the machine learning and natural language processing and graph-related data sets, geospatial data sets. They're kind of finding advantage in leveraging these in addition to many of the mathematical finance concepts. So when you think about the evolution of a quant, if you will, so you have to think about like, how can you leverage all these technologies and build those within your enterprise. So there are a lot of cool algorithms and data sets. So I'm not going to bore you with the details. I'll share some of the slides so that you'll be able to kind of understand some of the charts and things I've shared with you. But I wanted to kind of talk about some of the cool things which I see happening in 2021. And I was kind of looking at some of the research which has been happening, and I found many of the startups doing some really cool things in various spaces. But when you look at what's going to happen over the next year or so, and every year we have seen the whole area of machine learning and AI kind of enhanced in terms of like the various innovations. Over the last year, I've seen so many things happen, but I just wanted to focus on 10 things which I would like to just give you a preview of so that you can focus on those things as a part of your learning exercise over the rest of the year. The first thing I want to talk about is this focus on workflows. Now, if you have ever built a machine learning model, or if you've taken a class on, if you've looked at a machine learning model textbook, you will probably be just focusing on this aspect, which is, I'm going to look at like the various modeling techniques, supervised learning, unsupervised learning, potentially leveraging some of the different classes of algorithms, linear, nonlinear, black box algorithms, et cetera, et cetera. But the industry has moved on from just looking at these models. In fact, many of these could potentially also be delegated to like machines for leveraging Automl products like Data Robot. But the key thing is to focus on this whole pipeline, where you had to focus on ingestion, exploration, cleansing, feature engineering, building out and evaluating models, deployment, looking at drift, and then also risk management. So there's a huge emphasis on looking at the process and not just the modeling aspect. And if you look at the ecosystem of products which are coming out there, this whole notion of ML ops is, everybody's talking about ML ops. And if you look at the VC investments, there's a huge investment going on in the context of ML ops. Companies like Amazon, Google, Microsoft, they all have products and they all have different parts of the ecosystem focusing on enabling these, because people have come to realize that just having a really good model is not going to be sufficient. You have to have all these other components to have a successful machine learning project. So when you're building out your machine learning practice within your enterprise, focus not only on what the data scientists can do, but also how can you leverage your software engineering, your IT, and other parts of the ecosystem to basically have a smooth running process to have a whole machine learning workflow. The second thing I've observed is neural networks are becoming mainstream. And if you were talking about neural networks 3 to 4 years ago, deep learning was just coming into play, and people were very excited to look at some of the computer vision applications out there. But deep learning has significantly matured over the past 5 to 7 years. There are very many use cases in reinforcement learning and natural language processing, leveraging graph analytics and convolutional neural networks, recurrent neural networks, LSTMs. So there's been a significant maturity in terms of building and evaluating neural networks. Obviously, neural networks is not a panacea to all possible problems, but there are a niche set of problems where neural networks are really, really going to be beneficial within your enterprise. So I see that continuing to evolve over 2021 and in the future. Obviously, we are going to see some limitations, and we'll have to see what can potentially be done with those limitations. But especially in the context of natural language processing, we're still scratching the surface, and there are so many more RPA use cases, so many more chatbot and decision making and information retrieval use cases, which are still going to be feasible because of neural networks. So I see a big opportunity to adopt neural networks in 2021. The third thing we are kind of seeing is open source rules. And I just kind of going back to this slide I was telling you before, many of the innovations we have seen in libraries, in packages, both in neural networks, explainability, in building out computing infrastructure has come from the open source world. And what that means is access is not an issue anymore. You don't have to kind of go through hoops to just get access to something. Even trying out things is becoming so simple. You don't even have to install many products. It's all running on the cloud, and you can easily go with a sample problem to see whether it actually works. You can also, leverage many of the freemium models which are out there. So if you are ready to learn, try it out, build, deploy, maintain, you have the ability to leverage those products. But if you want to delegate certain things to organizations and say, I'm just going to focus on the development, let someone take care of the maintenance and someone take care of the various aspects of supporting the product in the future, ecosystems are evolving. So many companies are now being more and more comfortable with leveraging open source. And gone are the days when people would say, I really need an enterprise product. We have also seen a lot of enterprise companies supporting open source products because it's just kind of the need of the day. And you should be more comfortable with using machine learning products and other products which are built in the open source world. Now, we're also realizing that black boxes, even though are cool, and we don't have to think about building a model, and we don't have to work with equations, we just kind of give in the X and give the Y and let the model train by itself and see some cool results. We're seeing a lot of discussion on explainability and interpretability. In fact, we had many sessions in the fall school, and we're going to have a couple more sessions in the winter school talking about interpretability and explainability. And Agus gave a wonderful talk. Actually, he gave a talk at the summer school and also in the fall school, and both are available on Q.Academy for free. Please do check it out. But the point is, enterprises like Wells Fargo are also thinking about the importance of interpretability and explainability and building out infrastructure to support it. And I see that continuing to grow, definitely throughout this year, because people are not only realizing the power of machine learning, but also realizing that you will have to think about explanations, both from a regulatory perspective and also from adopting a responsible AI perspective. The fifth thing I'm kind of realizing is there is a real big need for high quality data sets. Garbage in, garbage out in machine learning, because if you do not have high quality data sets, if you do not have labeled data sets, if you do not have annotations, you will not have successful machine learning projects, despite having the best infrastructure, hardware, and tooling. It's all about the data, because these are data-driven problems. And if you do not have high-quality data sets, you will not have good results. And what that means is you have to think about, well, what's the cost of acquiring data? what's the cost of maintaining those data sets? And many a times you may have to do a significant investment of collecting data. And that would require significant time and effort, and you have dedicated organizations collecting data and providing it to you. But in the financial services world, history has occurred once, and we have only limited amount of use cases and things we can rely on. And if we are planning to build robust infrastructures for the future, factoring in various scenarios, especially this year when we have seen COVID and no one anticipated what's going to happen, and we saw the stock market swing like crazy in the last year, we will have to build infrastructure to factor in many of the things which are potentially plausible, but needs to be factored in, both from a risk management perspective, but also from an estimation and forecasting perspective. And we've seen a significant interest in building out augmented data sets and looking at subsets in various data sets, and also synthetic data generation to augment your use cases. And we have a couple of case studies in the programs we do to illustrate the value of leveraging synthetic data sets in your analysis. The next thing is COVID has accelerated digital transformation, and that's no longer a secret. And the inertia which a lot of companies had towards moving towards the cloud or moving infrastructure out of an ecosystem which they were maintaining, that's kind of gone. And I have friends who have been working on various systems which are predominantly cloud-based, and they've been extremely busy despite COVID in the last year or so, because a lot of organizations are realizing that if you're working from home, then how do you think about versioning? How do you think about infrastructure? How do you think about security? How do you think about automating various things when you don't have the luxury of having all the infrastructure in one setting? So there is a race to the cloud, and that's good, because what that means is cloud vendors are now going to be investing significantly in terms of security, in terms of enterprise needs. And from a financial services perspective, we are seeing a lot of growth in ways in which you can potentially leverage the cloud in terms of pre-existing infrastructure. So you don't have to reinvent the wheel. There are existing components which potentially could be leveraged. And then we're seeing ML as a service grow significantly. In the past, what has happened is, when people thought about building models, people would start out by saying, well, let me install TensorFlow, let me install PyTorch, and then start building a model from scratch. And everyone would start with the same models. It's like the hello world approach, right? So you have computer vision problems, you have natural language processing models, and you have financial problems. You would start from scratch. But people are realizing that we may not have the data to sufficiently train models. We may as well leverage existing machine learning APIs to use and build our systems and integrate with it. So our application, our machine learning application, is just going to be a collection of different services, and we're just invoking those services one at a time and leverage it. So if you're thinking about natural language processing, sentiment analysis, or if you're thinking about summarization, or if you're thinking about any other application in the context of geospatial applications or natural language processing or computer vision or whatever it is, the first place is to see if there is an API available, because you may as well get a better value in leveraging these APIs and integrating within your application rather than you building everything from scratch. So it's easier to try because most of them are using standard API signatures, and we have the Q sandbox where we are enabling trying out of different APIs. So we are seeing a lot of companies leverage these ecosystems to build out and expand the various APIs for machine learning models. So definitely check out machine learning APIs, because you don't have to potentially build anything from scratch. You can leverage pre-trained models which are readily available and hosted for you. The next thing we are kind of seeing is AutoML is making ML accessible. A lot of different ecosystem products which are out there. Some of them focused on scalability, some of them focused on hyperparameter tuning, some of them are open source, some of them are readily available. And a lot of companies are using these AutoML tools or automatic machine learning tools for benchmarking to see how good their models are, but also for some of the validation aspects. And also the beauty of many of these products are, you don't have to train yourselves or start hiring, PhD data scientists to start building out these models. You can take a softer approach by trying out whether these actually work for you. And if it works, then start putting in the infrastructure and the robustness to start building out technology. So AutoML was kind of a novel concept a few years ago, and a lot of companies are now kind of making it as, let's try machine learning through AutoML first, and if we see value, then we're going to potentially expand upon it. The ninth one is regulation is coming. That's something which we have been observing over the past many, many years, and especially in the context of model validation and risk management, we are seeing a lot of emphasis on regulations. And I don't know how many of you are following some of the things which are happening at Google in terms of AI ethics and fairness. And in Wall Street Journal, there was a feature, I think it was just yesterday. So please do keep track of like some of the things that are happening over there. But we also see many organizations like CFPB kind of issuing statements about what we need to do if we are leveraging AI and machine learning models for various credit processes. But we're also on January 13th, the Federal Reserve, in some of the prepared remarks, the governor, Federal Reserve Governor Lael Brainerd. So he had some statements, and there was also a symposium which is recorded and available online. So please do check it out, because we are going to see some regulations of using AI in financial services enterprises. And the last one is this whole notion of validation is kind of expanding, and people are now talking about algorithmic auditing. And there are multiple drivers to it. One, because we have ML as a service increasing, now people are asking like, well, how do I know if these models actually work? If a company is saying that I have a natural language processing API, and some of it, some examples I've given in here. So this was Pymetrics, which is a company which has technology which is used for candidate screening. So they wanted to self-police themselves, and they actually leverage some Northeastern University researchers to, and this is a paper called Building and Auditing Fair Algorithms. So they have like a transparent approach of what these algorithms do, and they had a third-party validator come in and take a look at their algorithms. So this was another one, Higher View, which was using facial monitoring. They leveraged an algorithmic audit by Kathy O'Neill, who runs an algorithmic auditing consultancy. And based on the report, they actually dropped some of their usage of certain algorithms. The New York City is regulating, it's coming up in 2021 or 22, I believe, on regulating algorithms used for hiring. So you're going to see a lot more effort in algorithmic auditing, having third-party validators come in and look at the models. And that becomes more and more important, especially if you're offering ML-based products. And also for companies like, in the financial industry context, if you're planning to use a natural language processing model, so you will have a question, well, how good is this model? What does it do in the context of certain biased use cases, or if there are edge cases or imbalance classes, like how does this model handle it? So one way to look at it would be to ask a vendor to provide the transparency, but then there's always going to be bias, no pun intended there, on what the models actually do and what's being advertised. You can go and do your own validation, but how many models are you going to validate? So this whole notion of algorithmic auditing is coming into play, wherein a third-party validator is going to come in and take a look at the algorithms and provide their qualified opinion. In fact, we at QuantUniversity, we do many of those kinds of efforts too. And that's becoming more and more important to safely adopt some of these existing AI and machine learning as a service algorithms. So we're going to see a lot more of these coming out in 2021. So we have a whole process of bringing some of these algorithms, and we have a sandbox, and we try it out and we validate it and then go with it. And we also do our own analysis and make sure that we augment some of the data sets to try out what if scenarios, so that the algorithms are validated as we progress. So those are like the 10 things we have. And if you're interested in trying out, we're running out of time a little bit, but if you're interested in seeing any of these demos, or if you want to get a feel for it, please do reach out to us, and we'd be happy to set up a demo and talk to you more about it. And as I mentioned, the best way to engage with us is through the school. We have a bunch of courses wherein we talk about the best practices, but we also are having many of these guest lectures. So please come back every week. And even if you're not learning everything, but getting a context of what's actually happening through the vision of some of the amazing speakers and researchers out there will help you augment your knowledge significantly. So that's kind of where we are. And I'm going to stop here and take some of the questions out there. If you have any questions, please feel free to put it in the chat window, or if you have any questions, please type in and I'll try to answer as many of them. So one question we have from Karoli: have you recorded the sessions from the Fall School 2020? If so, could they be replayed? The answer is yes. So if you, let me just share my screen again. So if you go to www.q.academy and filter on the Q lecture series, so all the lectures we have had in the fall and the summer school are readily available. You'll have to register to just get access to the labs, but all these lectures are available. So when you go in, you'll be able to see the slides which were presented and also the video. So you should be able to check out any of those sessions which you have missed so far. Another question we have: what is MLOps? So if you're looking at operationalizing a machine learning model, as I mentioned, there are so many components which you'll have to factor in, wherein you have to think about where does the data come in? What version is the data? How is it actually coming through the whole process, and what additional value are you adding? Are you doing some pivots? Are you doing missing value analysis? Are you doing some pre-processing of those data sets? And then how do you stage it? And how do you build out these models? And when you start building out these models, are you thinking about building these models in a single snapshot, or you're trying out like 6 different models and figuring out which model works best? And how are you doing versioning of these models? And how are you going to be deploying these models, and how are you going to be monitoring these models? And when you start monitoring these models, what does it actually mean? When do you think about retuning your model? And what does it mean if there is drift in your data sets? And what if the scenarios on which you had originally trained your model no longer exist? Or if the data itself has changed? So all those need to be thought about as a whole workflow in the process. And MLOps is ML operations, is kind of building out the infrastructure in addition to the modeling techniques so that you factor in each part of the workflow. So the way we define a model is no longer just like input, processing component, output. You kind of think about like all the 4 components, where like what's the data, what's the model, what's the environment wherein the model is operating, and what's the process it has to go through. So you kind of factor in all those 4 and operationalize it. And there has been a lot of innovations in software engineering and information technologies. So they call it like, continuous integration, continuous deployment, wherein there's a continuous aspect of modeling, monitoring, and then building out the requisite process so that you can operationalize some of these models in production. And that's basically what MLOps is. Okay, there is also a couple of questions on presentation. Yes, the presentation will be available on q.academy, so please do register. And if you'll also get an email on where to get the session. And there's also a question: if you're new to the field, do you have any suggestions for newbies? How do I proceed my study in QML? Well, go to www. I'm going to be biased a bit. Go to www.QuantUniversity.com, and we have many training programs. If you missed the first part of the session, I did introduce you to some of the courses we are offering in the winter school. We have, if you're starting fresh, I would recommend taking the Just Enough Python for Data Science course, wherein you'll get oriented with various Python-related packages. And then the machine learning course talks about the various applications you can build and various technologies which are out there. I teach graduate courses in these topics, and I've kind of summarized many of these topics from a practitioner's perspective, focusing only on the key ideas which you would need from a practitioner's perspective. But again, this is just me. There are so many other courses available, so please feel free to check it out. And also, I think you should just get your hands dirty. And I'm also a big advocate of just rolling up your sleeves and trying out a project. Try as many hackathons as possible. Try as many problems as possible. That way you get more proficiency. It's like cooking, right? So now you can read as many recipe books as you want, but unless you try it and taste it and figure out whether you like it or not, well, you won't be proficient with that. So do as many experiments as you want. There's another question. Is there any application that transforms the real world data and calculate the necessary parameters for optimizing the model on that specific quantum processable data? I don't know if I completely understand the question. Well, if it is space transformation on quantum data. So I think you should check out Luis Serrano's last week's event. He did talk quite a bit about quantum machine learning, if that's what I understand is the problem, the question about. But if you send me a note, I'll be happy to forward it to Louis to see if he can take a crack at it and answer that question for you. Okay, so I guess that's all the questions I have in here. So I'm very excited to see you all. And thank you again for joining us today. And I hope to see you every Wednesday over the next 8 to 10 weeks. And next week, as I mentioned, Patrick Hall is going to be presenting his amazing talk about AI response. And I look forward to seeing you all next week. So enjoy the rest of the week, and I'll see you back in another week. Take care. Bye-bye.